Hey everyone, my name is Neil Aryan. In this video, we're going to be talking a little bit more about EC2 instances. Um, if you haven't already watched part one to this two-part series, I recommend you do. In the last video, we covered what is EC2. We talked about the competitive advantages of EC2 and the different instance types. In this video, we're going to cover the pricing of the EC2, scaling of the EC2, and load balancing in the EC2. So in EC2, it uses pay-as-you-go pricing, and there's different kinds of payment plans that you can go opt for depending on your use case. And the different use cases that you can pick from would be, is your application able to withstand interruptions? Do you need to have your application running 100% of the time? Do you want your application only to run for a short amount of time, like less than a year? Do you need it to run 1 year or 3 years? Or do you need an extra layer of security and protection such that you need 100% runtime and complete discretion to your EC2 instances? So these use cases, for each use case, there is a specific plan. The first one we're going to look into are on-demand instances. And these are ideal for short-term workloads with irregular demand. So you don't really know how much demand that you're going to get. It's just that whenever you pay for these, you can add instances however quickly you so choose. These have no upfront cost. There's no long-term contract. They are the most expensive per unit of time because these pretty much go for however long you describe it for. It's not recommended for over a year because there's a similar plan for this for on-demand instances that lasts for 1 year or 3 years that saves you more money. It's also recommended for workloads that cannot withstand interruptions. These workloads would be mission critical and you need 100% uptime. And then let's look at reserved hosts. These are similar to on-demand instances in terms of what it can do. The only difference is it's a big discount based on how long you go for. So you go for a 1 year or a 3 year term, you're going to get a discount. So 1 year is not as big of a discount as a 3 year term. And the upside to this is you're able to extend the time of the instance until the term ends or after it ends. So for example, let's say I take a 1 year term and I realize that I want to use this for another 3 years. Then after the first year is over, nothing really changes. I just extend the contract to go for 3 years and then it'll add 3 years onto it. And if your term expires until you pay for another reserved host, you'll be charged at the rate of the on-demand instance. Now we're going to talk about dedicated hosts, and these are the most secure and most reliable of all of the instances. These are a physical server that are provisioned by AWS to be used entirely to your discretion. They're offered in only 1 to 3 year plans, and they're a bit more expensive than reserved instances. And these are used for absolutely mission critical workloads. And then finally, we have spot instances, and these are pretty much the cheapest ones, but also the least reliable. They feature around 90% discounts and are the unused capacity of other people's instances. They can be terminated by AWS at any given time, but they will give you a short window to save your progress or save your data. They should be used for workloads that can withstand interruptions. And for a workload that cannot withstand interruptions, once again, you want to choose on demand. And I believe there's always a couple questions regarding spot instances, on-demand instances, reserved, and dedicated hosts. So it's a good idea to get a good grip over what all the different instance types are. Next, let's talk about the concept of scalability. Scalability involves beginning with only the resources you need and designing your architecture to automatically respond to changing demand by scaling out or in. Now, the concept of scaling out or in and up or down is one that's hardly discussed, but there are questions that could come that will try to trick you with the terminology they use. So it's a good idea to fully understand exactly what they mean by out, in, and up and down. So scaling out and in changes the number of instances. So think of it as a fleet of cars, right? In this fleet of cars, you have 2 cars. Now you have 3, then 4, then 5. You're changing the number as you go out. But as you go up or down, you're changing what that car holds. You're changing the size of the instance and the compute power. Let's say you're adding files to this instance. You're adding a storage block to this instance. You're changing the type of instance. For example, you could go for a general instance and go into a compute optimized instance. So that's the difference between scaling out and up and down. So here we have a photo of demand and unused capacity over a week. So in this, we're gonna be coming back to this, but I'm just gonna give you an idea. As you can see, the demand is peaking on Wednesday, and there's a good amount of unused capacity on Sunday, Friday, and Saturday. So we actually use the autoscaler as a tool that's given to us by AWS to automatically increase or reduce the number of EC2 instances based on demand. Now, it's good to note that this is a free service. In case this ever comes up on your exam, just keep a note in your notes that it's a free service, so you won't have to pay extra for this. It scales down when activity goes down to save costs. So let's say you're on Wednesday, the autoscaler is going to put you at maybe 100 instances. On Thursday, when you're at less than 100% of what you were on Wednesday, say 60%, the autoscaler is going to scale down the number of instances that you have. They're going to reduce the number of instances. Then it scales up gradually as activity builds up so that it keeps up with the demand. So as you can see on, say, Tuesday, we have, say, 55% of the total capacity. On Wednesday, when it finds that there's a lot more demand, it'll automatically increase the number of instances so that your application can keep up with the demand. There also are components of elasticity, which we're going to be discussing in just a couple of minutes. So in auto-scaling groups, you can actually define how much or how little you want your application to have its EC2 instances scaled in and out. So a minimum size is a number that you set so that you never have less than a certain amount of instances, just so your application continues to run. The desired size is just a soft target for how many instances the autoscaler will have. And then you can scale out as needed. So it allows you to find how quickly the autoscaler adds or removes instances. For example, you can add 2 instances every 10 minutes when there is enough growth. And the maximum size is just the most number of EC2 instances that can be allowed. So let's use this example here. At 15% of your peak hour, you're probably going to be running on the minimum number of instances that you've set because traffic is pretty slow. When it peaks up a little more, 30% of your peak hour, you then reach your desired size. And this is how much you want this is what you define to be the desired size. And this will be what your autoscaler will like to stay at. And if it goes a little more to, let's say, 50%, you're still pretty much going to be at your desired size. But if the autoscaler finds out that now we're at 75% of peak hour and all of a sudden your desired size isn't enough to handle all the application demand, you're going to scale out as needed. You're going to start growing. The autoscaler is going to be adding instances to your fleet. And then finally, at 100% of peak hour, or let's say it's the most amount of demand you've ever had, your autoscaler is going to jump onto the maximum size and it's going to add as many instances as you allow it to. So that's a brief idea of how the autoscaler works. Now we're going to be talking about elasticity. Now, elasticity is defined, and this is from Wikipedia, the degree to which a system is able to adapt to workload changes such that provisioning and deprovisioning resources in an autonomic manner, such that at each point in time, the available resources match the current demand as closely as possible. Now, I appreciate in how much depth this definition went into, but I'm gonna simplify this. The ability to alter system function, capacity, and power to match the requirements to keep up with demand. That's pretty much what elasticity is. And you can see that it's pretty similar to a scalability, but it's not quite there yet. And we're going to be talking about a different application that deals with elasticity. So the elastic load balancer is an AWS service that distributes traffic across available instances to assure that no single EC2 instance has to do all of the work. And it's also there to ensure that there's no situation in which there are too many EC2 instances and it's kind of overkill for the amount of demand that you have. So it works with the autoscaler to signal that, hey, the traffic is pretty low. We don't really need these many instances. So what it will do is it will reduce the autoscaler will essentially reduce the number of instances that are in your fleet. However, let's say we're at 30% peak capacity and your instances are running as per planned, and all of a sudden it jumps to 50% and only a few instances get all that extra 20% of work piled onto them, and the other instances are running at normal. Now you have some instances that are doing way too much work and other instances that could be doing more. So what the elastic load balancer will do, it'll automatically redirect traffic so that each instance has to do an equal amount of work. And that's really efficient to make sure that no instance gets overworked. It reduces costs by working with the autoscaler to ensure that the number of instances at non-peak hours isn't too much, and it increases the availability of the application during peak hours by increasing the number of instances that are implemented. And that in turn increases profits. So now there's 2 periods of time that we're going to be talking about that the EC2 instances will either decrease or increase. So in a low demand period, it's going to decrease or stay the same, depending on what state it is. It'll never increase during a low demand period because it's less likely to have running instances that have no work to do. You know, we're removing instances here because we don't have enough work for all of them to do. So it saves compute costs and it reduces the complexity in your application by just removing different moving parts that are already there. It just decreases the number of instances so that, you know, you don't have too many instances doing too little work. And during a high demand period, your elastic load balancer and your autoscaler are likely going to increase the number of EC2 instances to keep up with the demand. And this is created so that you avoid having a few instances do all of the work, and this increases revenue and the availability of your application to your clients. Thank you for watching. In this video, we covered pricing of the EC2, scaling of the EC2, and load balancing of the EC2. In the next video, we'll cover messaging, queuing, and some of the additional compute services that aren't quite as important as EC2, but they will be showing up on your exam. Thank you for watching this video. Please like and subscribe and have a wonderful day.